Hey everybody, Matt here for Imagine Then Make. Thanks for stopping by. In today's video, this is going to be part 2 of teaching you how to program using Python. If you missed the part 1 or the introductory video, no problem. I'll leave a link in the video description of this video so you can check that one out as well. All right, let's get started by looking at the files we downloaded and installed at the end of the last video. So to get there, I'm going to click on my Start button and scroll down. And there's my folder, Python 3.12. That's what we installed at the end of the last video. Click on the little down arrow. There's our 4 items. I'm going to click on this one right here. It's the second item. It's called Python 3.12 64-bit. So when I click on that, it opens up a new window. Okay, and that's the name. That's what we just clicked on. And at the title, the first couple of lines here, Python 3.12.8, released on December 3rd of 2024. That's what we saw on the downloads page yesterday. 64-bit. Then it says here on the second line, type help, copyright credits, or license for more information. So let's try that. We're going to type in help, HELP, and press enter. And then it says type help, open and then close parentheses for interactive help, or help object for help about object. Okay, so I don't know about the English there, but okay. So let's type in HELP, open parentheses, close parentheses, and press enter. Welcome to Python 3.12's help utility. If this is your first time using Python, you should definitely check out the tutorial at, and then there's a web address. We're not going to do that, but when you get to this point, feel free. Enter the name of any module, keyword, or topic to get help. To get a list of available modules, keywords, symbols, or topics, enter modules, keywords, symbols, topics. So let's try that. We're going to enter in, first we're going to do modules. Press enter. Okay, so it took a second or two, I hope you noticed that, to create this very long list of modules. That's what I typed, help, and then modules. Please wait a moment while I gather a list of all available modules. So it's looking at my installation of Python, and it lists all these modules. So this is all code that comes pre-written and available right when you install Python. So there's a lot of stuff here. Landscape is vast, right? Okay, so let me see if I can just pull your attention to a couple of things we've already seen before. Like on the setup screen in the last video, I mentioned pip. It's like a utility program used to install additional packages to expand the power of your Python installation. And there's the pip module, okay? I also mentioned tkinter, or tkinter, still don't know how to say it. And here it is right here. This is code that can be used to create graphical user interfaces for your Python programs. Something I mentioned before, I'm interested in diving into at some point, not right now. I also mentioned in the previous video that I was interested in art, and specifically I'd like to learn how to use Python to draw animated lines to perhaps make a new video introduction to all my YouTube videos. And the module that I would use to do that drawing, those drawings in, is actually called Turtle. And we'll dive into this. So this is yet another module. And you can see that there's a whole bunch of other ones that most of which I don't know anything about yet because I don't need them. So I will learn about things as sort of on an as needed basis. I'm not going to study everything and then go back and actually try and do stuff. I'm going to try and do stuff. And if there's stuff I don't understand or need to know, that's when I'm going to look that up. Okay, so That's a pretty long list of modules. Once again, just showing you that the landscape is vast. Okay, so now let's try, the next one I wanted to try was keywords. Okay, so this is a much shorter list. These are words that the Python interpreter understands. It's sort of in their repertoire of words, okay? And it's a fairly short list, especially when you consider how many words are in spoken languages like English, a whole lot more than just these. And we will be using some of these words as we're writing code as we go along in this series, okay? So, let's see, the other one was symbols. Let's look at that. Okay, so these are symbols, some of which you will probably recognize, like this plus sign. That's the symbol for addition. You know, add what's on the left side to what's on the right hand side. This is a subtraction symbol, or a minus sign, a hyphen. Okay, meaning you subtract what's on the right hand side from what's on the left hand side. There are other logical symbols here too, like, well, this is less than or equal to. So that's a way to do a comparison between two numbers. Let's see, this / here, that's the symbol for division. And I think that's really a single asterisk, that's the symbol for multiplication. So we got addition, subtraction, division, multiplication. Of course, we got open and close parentheses. There's a bunch of other symbols that we'll come to understand on an as needed basis. And what was the fourth word? Keywords, symbols, topics. So let's just type that in for funsies and see what comes up. So right now we're kind of in the exploratory area of Python. We're just trying to get a lay of the land. So here's a list of available topics. Enter any topic name to get more help. So once again, this is one of those things that as we need to understand a particular topic, we will look into it, research it. Okay, so I just wanted to show you that when you run the Python item in the starts list, you're running what's actually called the Python interpreter. Let me get out of this. Okay, so I just typed in the word quit, which was in the instructions prior. To quit this help utility and return to the interpreter, enter Q or quit, spell the word quit. Okay, and so okay, so when we did that, we exited the help utility, okay, and it even announces the fact that we're leaving. You are now leaving help and returning to the Python interpreter. And you know, when you're in the Python interpreter, when you're running the Python interpreter, you get these 3 greater than signs, okay? So what is an interpreter? Okay, I'm glad you asked. So Python is referred to as an interpretive language. What that means is that you write your source code. It's basically a text file, and we'll start doing that soon, I promise. Once you write your source code, your text file, your Python program, okay, when you go to run it, that program goes into or gets read by the Python interpreter. And what the Python interpreter does is it reads what you just wrote, it reads what you sent it, and it evaluates it. Basically, it's looking for spelling errors. It's looking for any words that you may have used that it doesn't understand, okay? So as long as there's no typos and you haven't tried to use something that for whatever reason it doesn't understand, the interpreter won't find any errors, and then it'll go ahead and try and run the program that it just interpreted, evaluated, and it'll produce an output. Okay. Now, that leads me to say that there's two kinds of errors you're going to run into. And this is across the board, irregardless of what programming language you're working in. There's like typographical errors, spelling errors. It could be words, numbers, punctuation, anything that's spelt in a way that the Python interpreter doesn't recognize. It considers that a spelling error and it will flag it as such. The second kind of error is referred to as a logical error. So an example of a logical error is, let's say that we wrote a program that added two numbers together, let's say 4 and 6, okay? So 4 plus 6 equals 10, easy enough. Well, what if you typed in the symbol for, what if you typed in a minus sign instead of a plus sign? So then you'd have 4 minus 6, which gives you -2. That's very different than 10. So the program wouldn't know that you had mistakenly typed a negative sign, a minus sign, instead of a plus sign, which is what you meant to do but didn't by accident. That's referred to as a logical error. The interpreter can't detect logical errors. It can only detect spelling errors. So as you go along and you start writing more and more source code, you're going to make both kinds of errors. Spelling errors are the first things to look for when the interpreter catches an error and flags it. And then logical errors are the next thing you'll look for when your program actually runs without errors, but it gives you the wrong result or a result you didn't expect. Okay, so that's what an interpretive program does for you. So the interpreter is kind of like a helper. It's kind of like a helper program that reads and evaluates and then will actually execute your source code, your program, if it doesn't detect any mistakes. Now, when I say that Python is an interpretive language, that might imply that there are other languages that are not interpretive, and that would be correct. There's other languages like C and C++. Those are compiled languages. They go through an extra step. So they write the same source code, and then they pass that source code to the compiler program. It's like another helper program. And it too looks for spelling errors and so on. But then at the very end, if it doesn't detect any errors, the compiler will output, in the Windows world, it's an .exe program, a .exe program, which is an executable program, which once the compiler spits that out, produces that output, then you can run that .exe program and see if it operates, the way you expected. Are there any logical errors? That's what you would be looking for at that point. So compiled languages tend to run a little faster because they have this extra step of converting your source code into machine language that the computer can then run faster than an interpretive language where the source code is read by the interpreter, and then when it gets executed, it executes one line at a time as it gets reinterpreted. Okay, so that's kind of the 25-cent explanation. So there are interpretive languages, which Python is, and then there's compiled languages like C and C++, which Python is not. Okay, so that's kind of a little bit of an explanation. I hope that wasn't too confusing. So we're running the Python interpreter, and you know that it is the Python interpreter because it's got these symbols right here. Okay, so what else can you do in the Python interpreter besides run the help utility? Okay, well, you can actually type in Python commands and make it do something, make Python do something. So we're going to do that. Okay, so it's kind of tradition, and maybe you've heard this, that the first thing you do when you're learning, a programmer is learning a new language, is that you print on the screen a phrase like hello world. Okay, so in the Python language, the way you print to the screen is, or display something on the screen, is use, go figure, a print command. So I type in the word print. I'm going to type in an open parenthesis, a quotation mark, a double quote in this case, You could use singles, but we'll get to that. I'm going to type in hello world, close quote, close parenthesis. That's the end of my command. Now when I press enter, there you go. It displays hello world on the screen. Let me see if I can make that visible. So there it is. Hello world. Okay. So that's the very first Python program. Now, the issue when you run programs in the interpreter, it's very handy because you can type in something very quickly and see if it runs and see if it does what you expect it to do, see if you're spelling everything correctly and so on. So that's kind of useful. But as soon as I close this window and I go back and I restart the Python interpreter right here, it doesn't know anything about what we just typed. It doesn't even see that we had run the help utility. So it's a very temporary kind of environment. Here today, gone tomorrow. Okay, so obviously we don't want to spend a lot of time writing programs and have to retype the whole thing in each and every time. So what do we do to avoid having to do that? Well, we create a program file. So let me show you how we're going to do that. We're going to write the same exact program, only kind of in a different way. So we're going to scroll down again to our now familiar Python 3.12 folder, the down arrow, and this time I'm going to click on this first item, the idle Python 3.12 64-bit item. And remember, IDLE stands for Integrated Development Learning Environment. So it's a tool that you can use to write programs in and hopefully learn as you go. Okay, so I'm going to click on that. And now instead of a Python shell or the Python interpreter, now I'm running the idle shell. It's a little confusing, I think, but that's what it is. And it identifies itself with the same kind of header. Like it tells you what version it's running, when it was released, and so on. And there's the same kind of help type message. And look at that. Okay, we've got the same three symbols here. So if I type in the same command that I did in the Python interpreter, which incidentally, we're actually running the Python interpreter. If I type in print, open parentheses, double quote, hello, from inside the idle shell. Oops, can't spell. Close quote, close parenthesis. Okay, so there's a couple of things you should notice right off the top that's a little different than when we were typing in the Python interpreter that we got to by what I showed you earlier. Okay, now you can see that the text is actually color-coded. Okay, and so it's trying to help you, hence the learning environment. Okay, so let's see, let's run this and you'll see that it works, and then we'll try and break it and you'll see what happens when it's not done right. Okay, so there's our command. There's no errors, and here's the output. You can see the output is in blue, including my spelling mistake. Okay, so if I click right in here, let me see if it lets me fix it. See, I can't go in and edit this line. No, it won't let me edit the line. Nope. So it's kind of like you type it in and that's it. That's the way the Python interpreter works. There's probably some other tricks of the trade that are available that I'm not aware of, because quite honestly, I don't really use the Python interpreter. This is what I do instead. I go up to File and I click on New File. Okay, so here's a blank window. It's currently untitled. The file I'm about to create is currently untitled. So the first thing I'm going to do is I'm going to name it. So I'm clicking Save As, and I'm going to go to this folder on my external hard drive. And I'm going to type in, well, let's see. I'll use this name. And I'll say yes. Okay. So there's a new file called Hello World. I've obviously been playing around with this a little bit already. Hello_world.py. The .py indicates to the interpreter that this is a Python file and not an Excel file, a Word file, PowerPoint file, or a C file or a C++ file. No, all those programs have their own file extension. So Python's file extension is .py. Okay, so now if I type in print hello from, let's see if I can spell inside correctly, the idle shell. Okay, so once again, it's color coded, same colors. Right, so I've got, this looks like a purple to me, and light green. And then if I press enter, oh, it didn't execute. Okay, that's because it has not been sent to the interpreter yet. The way you send it to the interpreter is you run it. Okay, so what we want to do is we'll say run and then run module, and it warns me. It says save before run or check. The source must be saved. Okay to save. Say, and source means source code. That's what this is referred to as. That's my source code for the hello world.py program. So I'm going to say okay. Okay, so then it just sent that source code file to the interpreter. The interpreter read it, and it produced this output. Okay, so the advantage now is that I could open, well, I could go to recent files, and there's my source file. And so now I can change it. So I'm going to say hello and goodbye from inside the idle shell. Okay, now I already know that I need to save it before I can send it to the interpreter. So I'm just going to say save. And now I'm going to say run. And there it is. Hello and goodbye from inside the idle shell. Okay, so this is the process we're going to go through. We open up a new file in idle. We type in our source code. We save it with a unique name. And then we try and run it, which sends that file to the interpreter. The interpreter looks to see if there's any errors. And if it doesn't find any, then it produces an output. And it's up to us to decide if the output is indeed what we want. Okay, so hopefully that makes sense. Now, of course, you can have obviously more than, I hope it's obvious, more than one line in your source code file. And we'll just put another print statement in there. So I'm just going to say learning to program using Python is fun. Okay. Again, if I press enter, it just goes to the next line. It doesn't execute it. I could do either file and then save. Shortcut key is, or hotkey, Control S. Or I could go to run, which is F5. It's going to ask me, since I haven't saved it yet. Okay, so let's look at that. So you see this little asterisk right here. That means the file's been changed, but it hasn't been saved. So let me save it, And see, now that asterisk is gone. So while you're coding, okay, and your programs get longer and longer and more complex, and you've got all this stuff in your head and you're trying to keep track of what you're doing, okay, sometimes you'll just kind of forget to save your source code file. And that's a mistake that all of us have made. And it could cost you dearly if you wind up losing some of the text, some of your code that you just spent an hour trying to figure out logically where the mistakes were. So glancing every now and up again up here looking for the asterisk is very useful. And if it is, it's like I'll change this file and I'll put a bunch more exclamation marks. And you see the asterisk is back because idle knows that the source code has been changed, but it hasn't been saved. So now if I press Control S, which you can't, unfortunately, you can't see me do it, but now the program is saved, the asterisk is gone. If I hit run, there we go. Learning to program using Python is fun with a whole bunch of exclamation marks. Okay, so now that we have this, let's try and break it. So let's misspell print. So I took the I out and I put an O in, and you see that it's now a different color. That's because idle, the learning environment, has recognized that you have typed in a word that the interpreter doesn't understand what it is. There's an asterisk here, meaning the file's been changed but not saved. So I'll save it. I'll use the mouse so you can see on the screen what I'm doing. The asterisk is gone. Now if I hit run, okay, look at that. So let's look at this a little closer. So it tried to run, and it runs, the way it executes is it runs one line at a time as it reads them, okay? So it read the first line, hello and goodbye, from inside the idle shell, and it produced that output, hello and goodbye, from inside the idle shell, and it's colored blue, okay? Then it read this next line, pront, print with an O instead of an I, and it produced an error, traceback error, file, and then it gives me the file name, and then the name of my Python. Oops, I meant to make this window a little wider. So there's the name of my Python file. Okay, right there, rather. Line 2 in module, and it says prompt learning, blah, blah, blah. Name error, name prompt is not defined. Did you mean print? Look at that. It's trying to figure out what mistake you made and suggest that maybe you made a mistake. Okay, so that's pretty helpful. Again, I think that might qualify as the learning environment part of the tool. Okay, so if we go back up here and I change, because now I'm in debugging mode, right? I want to go back to my source code and correct the mistake. I'm going to take out the O and put in an I. And lo and behold, it turns purple, right? There's the asterisk, means it hasn't been saved. So I'm going to do a save. And then I'm going to run. Well, before we do that, let's do something else that changes it so we know that it's something different. So I'm just going to replace all those exclamation marks with an @ symbol. There's our asterisk. So we're going to save it. And now we're going to run. And okay, so it restarted the interpreter. It went to, it's reading, that's the file, right there. Yep. And it executed the first line, no errors, so it produced the output in blue. And then it read the second line, didn't find any errors, so it produced the output. And we know it's this line that it read because that's the only line we've typed so far with a gazillion @ symbols. Okay, so hopefully Hopefully that makes sense. That, in a nutshell, is how you write Python programs. Okay, if you remember from the earlier video, um, let's see, analytical thinking, right? The ability to break down complex situations or problems into smaller parts, systematically analyze them, and draw logical conclusions based on evidence and information gathered, often by identifying patterns and relationships within the data. So basically, said in simpler language, maybe. So when you go to write a Python program, what you have to do before you ever touch the keyboard, first you have to do is think about what it is you're trying to accomplish and make a list, maybe, of the things you want to accomplish. It's sort of like creating an outline for a story. I don't know, maybe you could consider it like that. I do. So you make a list of things you want to accomplish. And as you do this more and more, it becomes a little bit easier. But you make a list of what you want to accomplish, and then you start to think about how you would accomplish each one of those things. So which commands in Python might you use to accomplish whatever that item is on your list? And you just keep going down the list, down the list, writing all your source code, and then you save it, execute it, and then move into debug mode. Now, honestly, the way I've approached it since those high school days, when I programmed the high school computer a game, what I typically do is I'll break the whole program, the whole problem of writing the program to do XYZ, do whatever it's supposed to do. I break it down into tiny little pieces. And then I write a program that just does that one little piece. That's how I teach myself and encourage myself, verify for myself that I know how to do that one little thing. Then I move on to the next thing, and then the next thing, and then I start stringing those together. And so it's kind of like building a brick wall where you put the first brick down, and then you make sure it's steady and it's level and it's where it's supposed to be. And then you put the next brick on top of that, and you make sure that's steady and where it's supposed to be. And brick by brick, bit by bit, step by step, you write all these little, I call them test programs, little program snippets, just little tiny programs just to verify that you understand how to do one little thing. And by the time you get all the bricks put up, or you've written all your test programs and you have the whole problem fully understood at that point, how to solve it, then you can piece together all the little test programs and generate a finished program, which you can then run and continue debugging, make it more efficient, document it. That's a very important part of being a programmer. You need to document your code so that other programmers can read it and understand what you're doing or wanted to do. Because the two of you may not be sitting in the same room. You might not even be in the same time zone, so you can't even call each other. So, and sending text messages is, somewhat limited. You can maybe do a Zoom call or a Skype call, that sometimes helps. But anyway, the point is that you want to document your code before you call your program finished. And programs are really never, a programming friend of mine told me many years ago, programs are never finished, they're simply abandoned. Which is kind of a grim way to think about it, but in a way, I think it's true, right? So before you declare your project, your programming project finished, you want to make sure that you've documented everything that you need to document. So when you revisit that program a month, 6 months, a year, 2 years, 5 years later, you can read it and understand what you're trying to do, because you're not going to remember. So anyway, I wanted to kind of explain the process with a very simple, literally one-line program so that you can, well, so that I could discuss more of what this process is really like. So I think that's all I want to say for right now. We'll wrap it up for this video, probably way long anyway, and then we'll pick it up from here. So thanks for your attention.